Hello students! This week we're going to be talking about Chapter 3 in your Stanovich book. This covers reliability and validity. This is really important for how we measure things in science. So if you don't have a reliable and valid measure, then the results you're going to get are not going to be very useful. So we're going to dive a lot into this, but let's start with a little bit of philosophy. Essentialism versus operationalization. So why are we talking so much about philosophy? Our last class, assuming that I have this in order right after chapter 2, we talked about the philosophy of science. So how do we do science? We talked about falsification. So why are we talking so much about philosophy? Well, because science started from philosophy. So philosophy is about knowing lots of different things about ourselves, and one aspect of that was how can we know things? How can we get evidence to know things? How can we get evidence of and data for psychology? So it's really grown out of the philosophy of science. So it's the origin of many of the things that we started investigating in science. So there was a philosophical idea of this is how things work, and so studies were done, more empirical studies were done, to see if that was the case. So you could think of some of the first theories were philosophy around the areas. So again, PhD means Doctor of Philosophy in whichever subject area. So PhD in developmental psychology is you're a Doctor of Philosophy of Science in developmental psychology. So you know a lot about how to do research in that area. So it's really essential for what we do. I think this is a really good little comic, so I'll just let you read it for a second. Feel free to pause the video. All right, so hopefully you read that. There's sometimes maybe not to the point of physical altercations between philosophers and scientists, but science came from philosophy. The philosophy of science is all about how do we know what we know. So essentialism is the idea that any scientific theory is only valid if they reveal some kind of ultimate explanation of all situations. So essentialism is, can you explain every single thing about how the brain works, about how we behave, about how we think, some kind of ultimate explanation of everything. A lot of times essentialists like to argue over the meaning of words. So what is a construct? Making sure we're defining it the exact same way. So what is speed? How are you defining speed? Is that the appropriate way to define speed? And if you're trying to get to full understanding of absolutely everything, you've got to make sure you're pretty specific about things. So what is speed? What is radioactivity? It's still kind of a holdover from some philosophy. Not all philosophers do this. Some areas or some schools of philosophy do this and really focus on definitions. It can be a useful thing, and sometimes people also just use this to distract from the actual main points. But here, one thing that the book points out is that we as humans place value and meaning on things that are really closely related to our lives. So the reason that we are so concerned about intelligence, for example, is because it's something that we place a lot of value on. It's really important to us. It's central to what we think about ourselves. So understanding that, we put value on it. So intelligence is a really good example. I had an interesting experience with my first study I ever ran myself in undergrad. I told people, hey, you're going to come in, take an IQ test, then you're going to play a game of darts. We're going to see how well your performance is related to your IQ. That was a really bad idea. What I was actually doing was completely different, but I told them that they were doing an IQ test. It wasn't. It was a misdirect. I should have just told them it was like a personality assessment or something, because I told them it was intelligence. They were so focused on what was their IQ score that some of them didn't even pay attention to some of the next steps in the whole study. So with that, operationalism is a little different than essentialism. It's the idea that scientific concepts must be grounded or linked to one another to be effective and to be measured. So the concept of intelligence, what is it grounded to? What is it linked to? What are you actually measuring with that? So let's look at so with this operationalization is you are linking a concept that we're talking about in psychology or any science to something observable. So what is speed? Well, I might operationalize it this way. I might ground it or link it to this kind of measure. So miles per hour, for example. So it really makes us think really carefully and empirically about observations in the world. So I have this example here because we're going to talk about how do we measure happiness. So you could take the essentialism view of what is happiness. Let's make sure our definition of happiness includes absolutely everything and excludes anything. But operationalism would be, well, how do we ground a measure of happiness? How would we figure out how happy a person is? One example might be take a tape measure and measure their smile. And we'll talk about why that might not be the best measure. But this operationalism helps us to understand how we want to define a concept. It gives us an operationalization, a way to operate and measure that thing, that construct, in relation to other constructs. It grounds it in some way. It makes it more concrete, even when it's kind of a more ethereal concept. So, how do we operationalize speed? Just mentioned this, miles per hour. How do we operationalize radioactivity? I'm not actually sure what the measure is actually measuring, like a Geiger counter. What is that actually measuring? That's the operationalization of it, though. So how do we operationalize intelligence? So original IQ tests were really just a test of learning ability, like how quickly could you learn new information. Now there's Gardner's 8 intelligences and 8 different kinds of intelligences that you could operationalize each one of those, for example. So better operationalizations are often, but not always, more specific. So I just mentioned original IQ test was one specific number. It really looked at learning ability. Now there's other theories of IQ that have broken up IQ to its many, many things. Intelligence is many things. So for example, Gardner's 8 frames of mind include musical intelligence. That wasn't included before. So it's gotten more specific. A lot of times measures get more specific. This isn't always true, but it tends to be the case. So for example, measures of pro-social behavior might have been really broad, might have included lots of other related constructs. But something more specific might be a specific measure of altruism. And something even more specific than that might be a measure of heroism. So we're getting better operationalizations, getting at that one grounded concept that we really want to measure. So the ways that we define and measure concepts, constructs, variables really help other psychologists and other people know what we mean and what we're talking about. So you can say, I'm measuring intelligence, but IQ, that original number, was really measuring learning ability. And that should change how you talk about it. So am I measuring pro-social behavior? Am I measuring heroism? What exactly do I mean by that? So when you do that, when it's clear what you're meaning, what you're measuring, it really helps a lot of people be able to understand science. If you tell them I'm measuring happiness based on the size of a smile, we can have a conversation about that. We understand what the other person is talking about. So, empirical testing and operational definition is basically the description of how a variable is going to be measured. So this is operationalism. This is how I'm measuring happiness with this specific measure. This is my operational definition. So how should we operationalize happiness? Think about it for a minute. I've got a couple examples. I've already given one of them. But what is a way that we should operationalize or measure happiness? How can you actually get at how happy a person is? So pause the video, write a couple things down in your notes really quick. All right, hopefully you did that and you've got a few ideas of how you might operationalize happiness. Here's a couple ways we could or have in the past. So this is an example of one way you could possibly operationalize happiness. Everybody could use that, get a tape measure, measure people's smiles, and you might say this is how we are defining our operational definition. Someone who has a bigger smile is happier. Now we'll talk about if that's a valid measure in a minute. Spoiler alert, it's not. This is one way that we've been measuring happiness recently as well. So checking the chemical levels or like hormone levels in a person's skin cell or blood, like this one, a cheek swab. So that is related to the kind of hormones that you have going through your body. You can see how much oxytocin or any other chemical, dopamine, are in your body through those kinds of tests. And it might be related to how happy. If someone's got more dopamine, maybe they're more happy than less. And so you say that. This is my operational definition. If someone is over level 5 of dopamine, I'm just making up a number here, they're probably happy, right? So you can relate things. You might have seen a scale like this before. You can literally just ask people, how happy are you right now, right? You can give them some sort of survey. So will that always work in every situation? Well, probably not, right? But we'll talk about validity in a second. But if you've been to a doctor's office, you've probably seen a pain scale. So the faces on a wall, a little description like if your pain is level 10, this is what you're experiencing, versus if it's level 7, this is what you're experiencing, and some very sad faces versus some kind of mild or happy faces towards level 0 of pain, right? That's kind of what this is. You can have a visual scale of not happy to very happy. You could say depressed to elated, and you can ask people, how happy are you? So what is the best way to do this? What's the best way to operationalize happiness? Well, let's talk about it. So operationalizing a scientific concept does require measurement. So these are the ways that we are currently most commonly measuring happiness, both with those hormone levels, usually from a cheek swab, though some studies do a blood draw. It's just a little more invasive, so it's less common, as well as scales. So literally asking people, how happy are you? So with these need to be both reliable and valid to be accepted. So that's the main problem with this one. It's not a very reliable or valid measure. So it might actually be reliable, but we'll talk about that in a second. But not valid. It's not getting at truth of happiness, like how happy someone is. So from your book, write down reliability. What is your definition of reliability? What does reliability mean? How do you understand it? So write this down in your notes, or just review it in your notes really quickly. All right, so reliability is really synonymous with consistency or replicability. So reliability is consistency. Is any measure we're using, is it consistent? Is it replicable? Is it stable? Are you able to do it 2 times and it gives you the same number each time? So that is reliability. So if you give someone a survey of happiness, does that act the same way each time? If they feel like they're pretty happy on a scale of 0 to 10, maybe they say 7. And maybe tomorrow they come in, they still feel pretty happy. They should be getting a score of 7 out of 10. So if they come in next week and they still feel pretty happy that day, they get about a 7 on the scale. So that's reliable. It's giving the same result when someone feels that same way, right? So your bathroom scale. So if you stand on it and it tells you a weight, and then you step off of it and stand back on it, and now it's 10 pounds different, that's not very reliable. You don't really know what your actual weight is. Maybe it's in between those 2 numbers. Maybe it's completely outside those 2 numbers. You can't trust that measure because it's not reliable. But if you stand on the scale, step off, stand back on, step off, stand back on, and each time it's only like 0.1 pounds off, then you can be pretty sure that was a reliable measure. It's giving you a consistent result. And that's the thing. Reliability is consistency. So what about validity? How is validity different from reliability? Either put in your notes or review your notes really quickly for what is validity. I want this to be in your own words in your notes, both reliability and validity, to make sure you are understanding this concept. All right, validity is synonymous with truth or accuracy. So are you actually getting at the thing you're trying to get at? So are you actually measuring weight? Are you actually measuring intelligence? Are you actually measuring happiness? Are you actually measuring heroism? This is what validity is about. The truth or accuracy. Are you really getting at what you think you're getting at? So is the measure we're using measuring what it's supposed to be measuring? It's a lot of measure in the same, in a short sentence. So with this, are we measuring, if we have a survey of attachment, is it actually measuring attachment, or is it measuring something else? Is our survey of attachment actually ranking how much the child likes their parent rather than how attached they are? Because that's not what you want, right? If they're probably related, if you're securely attached, you probably will like your parent more, but we don't want to get a measure of how much you like your parent. We want a measure of attachment. So are you really getting at attachment? So this is a kitchen scale. We want a valid measure of something. Let's pretend we want a valid measure of IQ, right? So let's say I could do a lot of different ways to measure the different components of intelligence. But let's say I decide I really want a reliable method to measure IQ. So what I decide on is to take this kitchen scale, and then to test people's IQ, I have them come over and lay their head down on the scale. I have them do it 5 times, and I take the average, because with the kitchen scale it's probably off by an ounce or half an ounce each time. So I take the average number, so I've got the ounces of what their head weighs, and I use that as their IQ score. That's really not a good valid measure of intelligence, right? That's a reliable measure. I'm getting a consistent result every time. If you have them lying down their head on a scale, you're probably going to get a really similar result each time they weigh their head. But is that actually getting at intelligence? Is it valid? No, absolutely not. Just like the smile example, that's not a valid measure. Some people's smiles are bigger than others, even if they're not happy. Some people are actors. They can smile intentionally and have a bigger smile even if they are not happy, right? You can probably smile even if you're not happy. Maybe you're taking pictures and you're tired of doing pictures and someone says, smile, and you do it, right? So the tape measure example, it might be reliable. You might get a consistent measure of, I don't know how wide a smile is on average. Let's say 4.5 inches. So let's say you're getting a reliable measure. It's consistent each time, but that's not actually a measure of happiness, right? It's not getting at a valid answer about happiness. So validity is synonymous with truth and accuracy. It's also about, are the conclusions sound in our experiment? So we found these results. Can we actually say this is a true result? Can we attribute it to the study? Or is this from some confounding variables? So if you think back to our discussion of spontaneous generation and how that theory was taken over by theories of like bacteria, so those studies weren't always getting a valid conclusion because they didn't have control over all the variables. Some of the times the flasks or the cans or the bottles were not sterilized well enough, and so they got an invalid conclusion. So that's part of validity as well. So can your results be attributed to something outside the study? In the midst of your study, did an election happen and change people's moods when they did the study? This was an unfortunate thing that happened to us during one of the recent, well, now not so recent elections. We were doing a longitudinal study. And so we were following up with people. We had followed up with them like a week after they had did the study, and then a month after. And I think this was like the second, like a 2-month follow-up. We were so focused on doing this research, we didn't consider some outside factors. So we released this study. We emailed it to the participants the day after election results. So some people were very distraught about the election results. Some people were very happy about the election results, and it affected the data. So we weren't getting a valid answer of what we wanted. We were trying to look at purpose in life. And what we found was not about purpose in life. Some people seemed very upset that day. Some people seemed very excited that day. But the results from that one specific piece could not be attributed to our study. It was attributed to something outside the study. We did another follow-up a few weeks later, made sure that we were seeing the patterns still that we had seen before, and controlled for that, and basically used that data for a different paper about how the election results immediately affected people, which was pretty neat that we ended up getting some interesting data like the day after that. That's a little beside the point. So what validity you are concerned with is, are you measuring what you want to be measuring? Are your results attributable to what you want them to be attributable to? So when you're doing an experiment, when you're doing a study, you want to make sure that you're getting accurate data. That's getting at the concepts, the constructs that you actually want to measure. So reliability again, consistency, replicability. The scale for your head or the tape measure for your smile could give you a stable, consistent result that's replicable, but it's not valid. It's not truly or accurately getting at intelligence or happiness. So with that being said, let's show some other examples. A reliable measure might be like this thermometer here. So it's working, you put it in boiling water, show you 100 degrees Celsius, right? The scale, you're getting a reliable, consistent thing. Your bathroom scale, it's giving you the same weight each time as you step on it, maybe 3 times, hoping one of them will be lower or something like that, but it's giving you the same consistent measure. It's reliable, that's good. Unreliable measures are things that don't give you consistent results. So a broken thermometer or a broken scale, so step on the bathroom scale, it says, let's say 200 pounds, you step on it again, it tells you 150 pounds, you step on it again, it tells you 250 pounds. That's a really big difference, right? So a big range. So you wouldn't be able to rely on that measure. So first you need reliability. Your measure needs to be consistent. Then after that you can worry about validity. But you have to worry about both, right? You can't only be worried about reliability. So where does this kind of error come from in psychology studies? What makes things unreliable? Fluctuations in measurement, like the 50-pound difference when weighing yourself on the scale, that indicates measurement error. There's some error in the measurement. Are you 200 pounds? Or are you 250? Or are you 150? That's a big error in measurement. And this happens in psychology as well. So let's pretend we have a survey of prosocial behavior that says you get an observed score. 8 questions that you average together, and you say, okay, your average score for prosocial behavior is 7 out of 10. You're fairly likely to do some prosocial behavior. That is your observed score. That observed score is made up of the true score, so what your actual prosocial intentions are, and measurement error. There's going to be some component of measurement error. If you think of this in a microscope or telescope, maybe the glass has some defects. And so while you're measuring something, you might be a little off because of defects in the glass, right? So if you're measuring the air pressure in your tires, maybe you've got a little bit of error built into that device. Maybe if it's a digital or a mechanical one, there might be a little bit of measurement error. Generally, I find the cheaper ones that I buy have more measurement error than the more expensive ones that I buy for checking tire pressure, as an example. So in psychology, we're trying to observe our prosocial behavior intentions. So how likely are we to behave prosocially? That would be our observed score, and maybe we get a 7. I've got a 7 of prosocial behavior. Maybe my actual true score is 7.5. So if you had infinite knowledge that you could actually know someone's intention to behave prosocially, maybe their real true score is 7.5. So your observed score is 7, true score is 7.5, so that's about 0.5 of measurement error. It's not too bad in this specific scenario. So Here are a couple example items from an early draft of a purpose scale. I know it gives my life meaning, scored between 1 and 7. I strongly believe that people should care about something or someone other than themselves. I want to contribute to something beyond myself, scored between 1 and 7. Then average these together. So you'll get your observed score from these questions. And so some of that is going to be probably true score, probably, assuming that you're doing a good job making a valid measure. But some of this is going to be measurement error. So what you want to do as a researcher, you want to make sure that your measure, your observed score, represents the true score. You want to make sure that you're actually getting at the true aspect of the score and have very, very little measurement error. So if it's more reliable, you are probably getting at a true score. If it's less reliable, so you've got that 50-pound difference on the scale, there's a lot of measurement error there and it's not going to be reliable. So how do we test reliability? How do we see if the measure is reliable? There's a couple different ways. Because we don't have access to that knowledge of what a person's actual true score is. So what do we do to check? We have a couple different methods. Test, retest reliability, internal consistency reliability, and inter-rater reliability are 3 of the most common ways, but there's lots of other ways too. But these are what we'll talk about now in grad school. You'll talk about more ways to test reliability, but these are the most common. So test, retest reliability is essentially making sure your measure is consistent by measuring that same person 2 times. So you give them the measure of prosocial behavior or purpose, and then you measure them again the next week. You might expect for those constructs that they should be pretty consistent between those 2 tests, right? So if you have a test of intelligence, you'd probably expect it to be pretty similar 1 week after, right? So you test 400 people today, a week later, test those 400 people again and see if their scores line up. If there's too much difference, then you'd say this doesn't look reliable. It looks like we're probably getting too much measurement error. So with that, you should, depending on the construct, you might expect little change or a lot of change. So for IQ, you can expect very little change over the course of even a couple months. Over the course of a couple of years, you can expect some change there. So what you're looking for is essentially a correlation between all 400 pre-test scores to post-test scores of at least 0.80. So at the lowest, a really strong correlation. So getting really close to that straight line of a correlation. So one problem with this test-retest reliability is sometimes people remember how they answered the first time. So if you're giving them an identical test today and next week, they might just respond how they responded before. They might be like, is this a trick? And respond a little differently. So they might remember, right? So how do you get around that? Well, you can use alternate forms. So you might have seen this. Sometimes I give multiple forms of an exam. So I have like forms A, B, and C. Especially in an in-person class, I'll give multiple forms out. So anybody at a table has a different form of the test. So with that, you could use form A one time and then B the next time, or B the first time and A the next time. So it's the same kind of test, but it's not the exact same questions. So that's hard because then you've got to make multiple versions of the test that should be getting at the same construct. So that can be hard. So another thing that we do most often is internal consistency reliability. We test that measure at one point in time. So rather than test retest, we test one time and then break all those questions up and test them against each other essentially. So with this, all of those questions, all of those items should be measuring the same variable. Purpose, prosocial behavior. So you could think one early version of this before we had computers that were able to do this was split half reliability. So this is an easy one to understand. Let's say you have got 10 questions in your scale of happiness or prosocial behavior or purpose. You have 10 questions, split it in half, compare the first 5 to the last 5. If your average score on the first 5 is 6, your average score on the last 5 should probably be close to 6, right? So basically the 2 halves should be a similar score. Chromebox alpha is the most used measure of internal consistency, and you can do it by hand. And originally it was done by hand, and I did have to do this by hand in my stats class. And it takes a long time. Essentially, you're comparing all possible split half coefficients. So in that 10 item scale, you compare the first half to the second half. You also compare number 1, 6, 7, 8, 9, 10 to number 2, 3, 4, 5. Well, that wouldn't be half. So you can, any possible combination of halves, you calculate those mean scores and compare them all to one another. So it's still the basic idea of your test and retest, but you just measure them at one point in time, compare all the questions to every other question, all possible combinations of the questions to the other combinations of the questions, to make sure that it's internally getting at a consistent answer. So with this, it's correlated with every other item on the whole thing. And so just like the correlation, you're trying to get above 0.8, you want a Chromebox alpha above 0.7. You don't want it to be identical questions, so you don't really want it to be above 0.9, but you want them to be getting at the same thing. You want it to be reliable, but not 10 questions asking the exact identical thing. So here are our scale examples. So we've got 6 questions here, trying to get at purpose. Split half reliability would be taking all the blue questions and comparing it to the red questions. So these are the scores from 4 people. So one person got 14 on the red questions and 16 on the blue questions. This person got 15 and 15, 16, 14, 13, 12. That looks pretty consistent. And essentially with coefficient alpha, you do that in every possible combination. Odds versus evens, the first 3 versus last 3, the first 2 and last one versus the middle ones. You do all sorts of all of those. And yes, you can do that by hand. It just takes a while. So that is what we most commonly use for survey measures, is the internal consistency reliability. And we talk about it in terms of an alpha value. So inter-rater reliability is the extent to which raters agree about their observations. And I've got a little video to go along with this one. So let's hope the quality is good enough by me watching this and recording it at the same time to get the point that's getting across. That one's fine. I actually like this one the best, which is why I made it bigger. So what we have here, you can see all 3 of the people at some point. 3 raters, so 3 people that are rating this child's reading ability. So they're reading a paragraph, and these 3 have a computer program that they're basically seeing what the child is reading, and they're marking any errors, like did they make pronunciation errors, they say the wrong word, these kinds of things. So there's 3 people rating this at the same time. So it's low quality, but try to see what they're doing on their screens.
A F O I A Z E Ş Ü V A S N T I J M L A W J U O M L P T J C V A R K B U S F et accent grave. J S C A L E D A Y F H I U P S P.
So hopefully you can see well enough in the recording of this screen capture that there are a couple things marked on this rater's computer. So as the child, it sounds like they're reading sounds, maybe they're learning a new language or just going over the alphabet. But basically, as they're reading these, they're marking things that are incorrect. So you might be able to tell this rater has marked more things incorrect than this rater, but most of them do match up. It looks like maybe one thing this rater caught that this rater did not catch. So that's what inter-rater reliability is about. It's about making sure when you have multiple observers that all those observers are seeing the same thing. So we'll see how they conclude this measurement.
P M N V Y T Z E J N Z N A F D O D B A E.
And here you can see this person marked a few more things than this person did as well. So my guess here, because I think they're speaking French and my French is so poor, is that these are teachers. So these are the teachers of this child. They're testing this child on a specific skill. So they are all rating. There's 3 raters here that are checking the pronunciation of words, things like that. So with this, they're coming together and they're deciding, hey, did you see this error? Did you see this error? Did you see this thing was good? What was your interpretation? If there are differences between them, so this person seemed to have caught less, this person seemed to have caught more errors, so they can talk about them. They can talk about, well, what did you see or what did you hear? So that's one thing that inter-rater reliability is trying to get, is making sure people are consistent in what they're looking for. So I really like that example. There's a couple other ones here, but I think that's the best to really show how inter-rater reliability is done in practice. So that's one way you can test. You can see if looking for attachment in an attachment situation, does everybody think it's the same attachment? If you're measuring prosocial behavior on the playground and you've got 3 people watching the playground, I counted 8 prosocial behaviors. How many did you count? Oh, you counted 9. Okay, great. That's pretty close. Oh, you counted 17. That's a lot different, right? So you want to make sure that your raters are agreeing about their observations. Tools like the computers having something that you're specifically looking for while going through an observation is a really good way to do that and make it better. So that's one of the reasons I really like that video, even though it is pretty difficult to see. It's pretty old. I've been using it for quite a few years. But it's one of the best ones I've found to really demonstrate how inter-rater reliability works in practice. So that is some of the main ways that we measure reliability in psychology. But what do we do to see if a measure is getting valid data? So remember, reliability is consistency. Validity is the truth and accuracy. Are you actually getting at someone's ability to speak a language? Are you actually getting at someone's happiness level? Are you actually measuring how likely someone is to act prosocially? That's validity. So with this, what do we do to see if a measure is valid? Well, one thing we do is look for construct validity. So our construct might be happiness or prosocial behavior. Does the operational definition, the way we're measuring it, does it reflect what we think should be measured? So purpose should be measuring purpose in life. It shouldn't be measuring just meaning, like someone who feels they have a lot of meaning in their life. They're similar and they're overlapping, but one is the construct of purpose, so are we actually measuring that bit? So a good example of this is that you might find a lot of meaning walking through nature. You might go on a hike and say, that was really meaningful. I'm really glad I did that. It's a very meaningful activity to me to walk through nature. Versus a purpose has to have a couple other components. To have a purpose in life, it has to be like long-term and short-term goals. It has to be meaningful to you. And it also has to be beyond yourself. So protecting nature would be a purpose. Walking through nature would be a meaning. Obviously, if you have a purpose in protecting nature, you might find meaning in walking through nature. But you want to be measuring the piece you want to be measuring, right? If you want to be measuring purpose, you need to get at those components of the construct and not be measuring something that's related but not the same. right? So if I want to measure heroism, it's very related to pro-social behavior. You might even put it in an umbrella, like pro-social behavior is the bigger umbrella and heroism is like a really specific kind of pro-social behavior. But if I want to look at pro-social behavior, I want to look at that broad range of behaviors versus heroism. I want to look at that really specific thing. So content validity doesn't measure all the components, symptoms, or most parts of the construct. So a scale of purpose, like I just mentioned, needs to be measuring those beyond the self concerns. Are these concerns that you're oriented towards or you find meaningful? Are those beyond yourself? Things like family are really common purposes. The well-being of others, nature, these are pretty common purposes. A lot of people find purpose in religion as well, or like their deity and their religious beliefs. So that's beyond themselves. That's something outside themselves, right? And this is meaningful and it's goal-oriented. Gives generally long and short-term goals. So a scale of purpose needs to have all three of those things. So face validity is another way, one of the most common ways that we measured validity in the past. It's also one of the worst. So it's essentially the idea, does this measure look like it measures what it's supposed to measure? Does it look like it has construct validity? When I read these questions, does this look like pro-social behavior? When I read these questions, does this look like it's going to measure heroism? So a lot of previous research did that. Focused just on face validity, and that's where they stopped. It's a really poor standard. It's a good place to start, but it's not the end-all be-all. It's not the only thing you should have as evidence of validity. So Claremont Purpose Scale, based on the definition I just gave you of beyond the self-concerns, meaning and goal orientation, take a look at these questions. See if, do you think some of them are getting at goals? Do you think some of them are getting at meaning? Are some of them getting at being concerned beyond yourself? These ones are actually supposed to be getting at meaning. These ones are supposed to be getting at goals. And these ones are supposed to be getting at concern beyond yourself. So face validity is, I look at this measure and I say, yep, that looks pretty good. A good example of using this appropriately is actually my dissertation study was to create a scale of intended heroic behavior, or studies. And so one of the first things I did is I made a bunch of questions that I thought looked like they probably had face validity, and then I asked heroism experts, like other researchers in the field, people doing heroism programs. I said, hey, does this look like it fits your definition of heroism? And I let them rank it. Yes, no, like on a scale of 0 to 7. So that I used that as face validity first, and then I took additional steps to get things like construct validity. But that was the first step I did. Make sure first it has face validity, then move on after that and find other types of validity. One that might be useful is predictive validity. Does your measure predict something? If it's supposed to be predictive of something, does it actually do that? Does it actually predict how likely someone is going to be pro-social? So the SAT and GRE are trying to predict, or the prep tests are trying to predict how you will score on the actual test. So a good one would be more useful, right? You would want a SAT prep test or a GRE prep test that actually does have predictive value. So if you score, I forget what the score ranges are for each of those measures, but let's say 100% is the top. That's not how they score them, but let's say 100% is what you want, and one that you're getting 90% on each time, you find to be the most predictive, and you end up getting like 90% on the actual GRE. That's what you want. You want that predictive thing to do prediction. So you can test that. Convergent validity is testing the measure to see if it's showing the same thing as other measures of the same thing. So if there's already measures of purpose, if there's already measures of pro-social behavior, is your measure converging with them? So let's say you're making a new survey for attachment. One of the most common ways to measure attachment is actually in an observation of a home situation or the strange situation. So you can do that observation as well as give the survey and see if they line up, see if they converge, if they're giving the same response. That's good evidence of your new survey measure. Discriminant validity You want to make sure that your scale is not related to things that it shouldn't be related to, right? If I want my measure to be measuring heroism, it should probably not be measuring things like social desirability, people wanting to do things for socially desirable praise, for example. So I should discriminate against that, essentially. My measure should measure heroism. It should not be well correlated with social desirability. So these are not negative correlations. Discriminate validity means it's not related to it. So pro-social behavior, you'd probably want to see the same thing. You would want it to discriminate and not be correlated at all to someone who is trying to give socially desirable answers. Right? You want to get at the real, actual, valid behavior of pro-social behavior, not at someone who's trying to make themselves look good. Right? So it's not that you want a negative correlation, you want zero relationship here. That's discriminant validity. A measure of pro-social behavior, there really should be no reason why it would correlate with arachnophobia. Like, it's kind of a silly example, but why would pro-social behavior be related to arachnophobia? Probably wouldn't. So you wouldn't want to see a negative or positive correlation with your pro-social behavior measure and arachnophobia. So because it's something that just shouldn't be related to it. Incremental validity, if you're comparing your new measure to a measure that's already established, you want to show that yours is better in some way. Does it get at more of the components of the construct? Does it get more honest scores? So some way is it performing better? That's incremental validity. So reactivity is related to measurement, but hopefully those examples are really good for reliability and validity. Some of the most common are convergent validity and construct validity. So construct validity is a really big umbrella. It includes things like content validity and convergent validity. So reactivity. When you are measuring someone, a person, generally they tend to change their behavior due to the awareness of being measured. So we want, as psychology researchers, we want to measure people in as natural of a state as we possibly can. So if we want them to be, if we want to measure someone in a scared state, we'd like them to be in that scared state, right? Generally, though, what we want is just people to be as natural or normal as they can be, as they would be just in day-to-day life. But when you give someone a survey and you say, hey, do this, they know they're being measured. They know that's going to be looked at. And so they could be reactive. It could change their responding to those measures. Have you ever gone to the doctor to get maybe your blood pressure checked? And maybe you know you're going to get a shot later, and so you're a little more nervous. Maybe your blood pressure goes up because you're a little nervous of the upcoming shot. That's an example of you're being reactive. You're changing your behavior. Your heart rate is going up. Your blood pressure is going up because you're reacting to the situation. So if a person realizes that you're trying to study them, which generally they know because you're giving them a consent form, you're asking if you're getting informed consent from them. Some participants will try to help you in your study. Some might try to hinder you in your study, and we don't want either of those. Some participants will think they figured out what you're trying to measure and try to make it look that way. Some people will be not very happy with what you're measuring and try to make it all screwed up. So you don't want that behavior. You want to try and keep people in just as natural response as they will be. One thing that I've seen in some surveys is if you don't include someone's ethnicity or gender in like the demographic variables, it might make them really upset. So there's been surveys I've seen from, say, other researchers and historically that they used to, say, have a demographic variables at first and realized that's a really bad idea. Because if you haven't included someone's ethnicity, if the age range doesn't include their age, like if there's a slider and you don't expect someone to be 76 in your study, and so it doesn't even go there, someone's going to be annoyed by that. If you don't include their gender, that's going to be annoying to them. And so they might be reactive and not respond to your study the way they would normally if they hadn't been reacted or had something like that happen to them. So let's talk about concepts, constructs, and variables. We've mentioned a few of these points before. A variable is essentially anything that can vary. So a person's height varies, right? So my height is probably different than most of the students' heights. Some of you might be exactly the same height as me, right? But that's something that can vary between people. So age is a variable. Your happiness is a variable. It's anything that can change, anything that can vary, anything that can vary between people. So my intentions to act pro-socially might be very high. Yours might be very low. Mine might be very low. Yours might be very high. So basically, all right, so yes, a variable is anything that can vary between people or even in any individual. That is what a variable is. So with this, age, height, BMI, IQ, happiness score are all examples of something that could vary between people. A construct is basically the same as a concept. So oftentimes I'll use the terms construct and concept interchangeably, and sometimes those do line up with a variable. Sometimes they do not. So the construct of attachment, the construct of heroism is this idea around some kind of thing, some concept. So my variable that I'm measuring in attachment might be, I might measure multiple variables to get at the construct of attachment, or sometimes when I'm talking about a construct, I might be talking about just measuring it from one variable. So with this, a variable is, most are defined indirectly through the operationalization of it. How are you grounding this? How are you grounding this variable? So, and how is it in relation with the other theoretical constructs? So, for example, heroism. Heroism is the main variable. How I'm grounding it is through the questions that I'm asking, the questions in a potential heroism scale. So these questions are what I would call civil heroism. That's another construct that makes up the main construct of heroism. So these are the heroism is the variable, and these are the grounding of it, the operations, the survey questions. So CH3 is literally one of the names of the survey questions that I made. So a latent construct is not directly defined by observations, but linked to those that are observed. So these are the direct observations, the individual questions in a survey. These are the latent constructs. So the variable in this case is a latent construct. So with that, it's always grounded, it's always linked to these specific observations. So all 8 of these questions is what I call their heroism score. Versus these 4, I call their civil heroism score. These 4 is their socialism score, or social heroism score, and then put them all together for their heroism score. So here's a bigger example of that. These are kind of like correlations, so how strongly each question is related to this construct. And so you see these concepts are pretty much the same strength of relationship to the main concept. So this is another way to demonstrate it. Ended up finding out that this was the best model to demonstrate, to show how these constructs are related to each other, not as civil and social being part of heroism, but as these questions being part of heroism. And then you could also look at the data separately, but some other validity studies I did showed that that wasn't, at least right now, the evidence suggests that looking at them as one heroism construct is the best, not as separate constructs or separate variables. So with this, the evolution of variables and constructs changes. So how we think it should be measured, the kind of ways we ground it can change. And so one thing we already talked about is usually measuring of a construct gets more specific. So previous measures of purpose, for example, looked at meaning and goal orientation. They had those 2 pieces in it. We made a new measure of purpose that included the 3rd piece of beyond the self concerns. So the construct was understood more specifically. We made a more specific measure, so it evolved as the ideas around this. So with this, we have beyond the self concerns. That's one theoretical system. Meaning is another theoretical aspect of purpose, goal orientation as well. So with this, generally, valid measurements get more and more and more specific. It's not always the case, but to get from pro-social behavior to heroism, it's a lot more of a specific thing you're looking at. The previous purpose scale looked at meaning and goal orientation. Ours looked at the 3 components. So, evolution, so with this in mind, memory in the past was measured in a couple different ways. One of the main ways was looking at how many random words or random letters or random digits you could remember in like 5 seconds. Now we look at things like semantic memory, episodic memory, working memory, iconic storage, acoustic memory. So there's a lot more specific things we are getting at that is what we used to call short-term memory. So we've gotten a lot more specific. There's specific operationalizations for what semantic memory is versus working memory, and specific ways to measure those pieces. So here, the construct is memory, and the individual I would also call semantic memory. I would call each of these individually variables as well, but in this case too, they are also constructs. Sometimes that's the case, sometimes it's not. So that purpose measurement evolved from measuring those 2 pieces of a construct to now it's 3 pieces. Heroism has evolved to measuring it this way, and I suppose, and I even suggest in my paper, ways that it can be improved, its measurement can be improved in the future. So, numbers in context are really important. So let's talk about a thing called the Gleason score and cancer. So a score of 2 out of 10, basically, it's a score that ranges between 2 and 10 that says how ominous the cells look, how likely it is that those are actually cancerous cells and are going to be spreading. So a score of 6 is actually the first level that's operationally defined as cancer. So 6, 7, 8, 9, 10, all really bad. 5 is something that you'd be watching, but you wouldn't actually call it cancer. You wouldn't need to do like radiation treatment. But seeing a 5 out of 10 looks pretty scary, right? 6 out of 10 sounds pretty bad. But actually, 6 out of 10, even though it's something that you would operationally define as cancer, means that you only have about a 1% chance of dying from that specific cancer in the next 10 years. So this is specifically with prostate cancer. So 6 out of 10 sounds bad. It's technically cancer at this point. But a 1% chance of dying in the next 10 years, you still want to do something about that. But rather than radiation or removal on this specific kind of cancer, not all cancers, but this specific kind of cancers, the current idea is to watch it, to see if that gets worse. And then if it is getting worse, then it would go up from 6, 7, 8, 9, 10 and removal. But when it's 6 out of 10, that might sound bad. You have cancer, but for this specific cancer, you don't actually need to do anything other than monitor. So recently the World Health Organization says, hey, we should really update this grouping and these rankings to make it a lot more clear for people. So they said, let's make it groups 1 through 5. So a Gleason score of 6 is now group 1. And that's a lot less scary. When you say, how bad's my cancer? Well, on a scale of 1 to 5, it's a 1. So we just need to watch it. It's a lot more clear to a patient. That's a lot less scary to a patient. And that's an important context to understand when you hear, well, it's 6 out of 10, this is cancer. That's probably a lot more scary. So the context around the numbers is important. And this goes for all kinds of measures. So, quick review on some of the concepts we've talked about. Actually, before that, let's talk about this number in context. So what does your number for the smile mean? So measuring with a tape measure, well, really that's just the centimeters of your face. That's the context. It's not getting at valid data, even if it's reliable. your cheek swab of hormone levels, the context of those numbers might matter. What is the normal or average level for a not a happy or a sad mood, for a content mood? Like, what is the context of the numbers? So knowing the numbers and what their context is very important. If everybody is scoring 9 out of 10, is scoring a 9.5 out of 10, is that really dramatic, or is that not very dramatic? So knowing the context around numbers is very important, and part of what we need to do and make clear in research papers as we're explaining things like the results, how impactful they are. So a little review. Essentialism, a lot of argument over meanings of words, trying to get at some kind of ultimate explanation of things. So the way something's defined is really important. And operationalization, and still important how you're defining it, but generally these definitions are linked to something measurable. So purpose, measuring it through these survey questions. It's grounded in something real. Happiness, grounded in your response on a happiness scale or your hormone levels. So it's grounded in something observable. And so a lot of these are operationalizations of variables. Reliability in a measure is it consistent? Does it give you the same score each time? Are all the raters giving the same response? Did they all see the same number of mistakes? Did they all see the same number of prosocial behaviors? Versus validity is truth and accuracy. Did you actually measure happiness? Did you actually measure purpose? Did you actually measure intelligence? So it's really important to first have that reliability, be consistent so that you're not getting a lot of measurement error. And then if you're being consistent, you're getting at a true score. Is that true score truly the valid thing that you're trying to measure? Is your true score on purpose actually getting at purpose, or is it actually getting at meaning? Because you want to be specific. So that is all of chapter 3. A lot of examples, some things that are probably new concepts to you, but hopefully all our examples throughout were really helpful in understanding reliable and valid measurement.